Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In previous two videos, we saw how to determine the shearing strength and bearing strength of bolt. We know that the failure of bolted connection may be due to failure of bolt or failure of plate. Now, today we will see how to find out the strength of the plate in tension. Okay? So, let us see. Whenever we are connecting two plates by bolting for bolts, you have to make the holes in those plates. Due to those holes, the plate becomes weak at a particular section, and at a weakest section, the failure of a plate takes place. Such a failure is governed by rupture at net cross section. Therefore, when we have to find out the tensile capacity of the plate, we have to consider the rupture at net cross section. Now let us see how to calculate it. Now, as per clause number 6.3.1 of IS 800/2007, the tension capacity of the plate is given as TDN. D is design tension capacity at net section, N for net, is equal to 0.9 into Fu into An upon gamma M1. Now let us see what are these terms. Fu is ultimate stress in the material of the plate. An is net effective area of the plate. Gamma M1 is partial factor of safety for resistance due to ultimate stress. Okay. Now what is An? At a particular cross section where the plate is weak. Okay. So that area is known as net effective area of the plate. Okay. For chain bolting, An is calculated as B minus N into D0 into T. What is B? B is the width of the plate. What is T? T is the thickness of the plate. Okay. What is N? N is the number of bolts along that particular section. D0 is diameter of the bolt hole. Okay. So B minus N D0, because this much distance will be cut from this B. So this is the value of B, that is the width of the plate. Okay. Now if it is zigzag riveting, now if I say that I want to find out An at this section, now what will be An at this section? An is equal to B. B is width of the plate minus N D0. Now what is value of N for this section? 1, 2 and 3. D0 is diameter of bolt hole, and sigma P square upon 4G. Now what is P square upon 4G? For this one, it is p square upon 4g. For this one, again it is p square upon 4g, summation of 2. So it will be 2 into p square upon 4g into t is the thickness. Do you understand? Therefore, what is AN? AN is net effective area of the plate for chain bolting. This is the chain bolting. Okay. If this is the critical section, it will be B minus ND. What is value of N here? 2. Into D0 is diameter of the bolt, multiplied by T is the thickness of the plate. For zigzag riveting, you can see here, this is zigzag riveting. This P is the staggered pitch. Okay. So it will be increased. What it will be? AN will be again B minus N D0. What is value of N? 1, 2, 3 into D0 is diameter of bolt hole plus summation of P square upon 4G. That means this is 1, so P square upon 4G. This is another, so P square upon 4G. So again it will be 2 times P square upon 4G multiplied by, bracket multiplied by T. That is the thickness of the plate. Do you understand? Okay. So all the terms are cleared. AN is net effective area, B is width of the plate. If B is not given, then per pitch length it is calculated, it is taken as pitch. N is number of bolts which are coming across that section. D0 is diameter of bolt hole, T is the thickness of the plate, P is the staggered pitch, G is the gauge. Okay. So this is how we can find out what is the maximum tensile force which can be carried by the plates. Now let us solve one problem by which it will be clear. Let us solve this problem. 2 plates of grade Fe410 are connected by a single bolted lap joint. So single bolted lap joint means like this. The bolts are of diameter 20 mm and they are provided at a pitch of 60 mm. Okay. Calculate the tension capacity of the plate. Take the thickness of each plate as 10 mm. So this is the problem which we have to solve. Now what are the things given in this one? The width of the plate is not given, pitch is given, therefore here we will consider one pitch length to find out the tension capacity. Therefore B is equal to pitch is equal to 60 mm, diameter is 20 mm, therefore diameter of bolt hole is 20 plus 2, that is 22 mm, thickness of the plate is given 10 mm and ultimate stress in material of the plate is 410 MPa. Now before we use the formula of TDN, let us first calculate the net effective area of the plate. Now this is chain riveting, so net effective area is equal to P minus ND0 into T. Value of P is 60 N. Okay, what is N here? N for per pitch length only one single bolted. Okay, so single bolted lap joint, so it is in one pitch length it will be one only, multiplied by D0, that is 22. Okay, multiplied by 10. Okay, which comes out to be 380 mm square. Now after calculation of AN, we can calculate the design tension capacity of the plate TDN is equal to 0.9 into Fu into An upon gamma M1. It is 0.9, Fu is 410, An is 380 upon 1.25 into 10 raised to 3. Again, to convert TDN from Newton to kilonewton, it is divided by 1000, and if you calculate it with the help of scientific calculator, you will get the answer as 112.18 kilonewton. Okay. Now, you may have the doubt that the type of connection is this one. Here there are two bolts. Why I am taking one bolt? Now here this is the width of the plate. Here width of the plate is not given. Only one pitch length we are considering. So if you take this is the pitch distance, then half bolt in this and half bolt in this. So again it will be 1. Do you understand this? Okay. So like this. See here. If I say that this is pitch, then this is one pitch length, because B is not known to us. This is the pitch. B is not given. So here you can see that in one pitch, half the bolt hole on this side and half the bolt hole on this side. So totally it is 1. If we would have given the value of B, then we might have taken B minus N D0, that is N will be, in that case it will be 2. Do you follow this? This is how we can calculate the tension capacity of the plate. So in this manner, we have calculated the strength of the plate in tension. Now, in these 3 videos, we found out strength of bolt in shearing, strength of bolt in bearing, and strength of plate in tension. In the next video, we will see how to find out the strength of bolted connection and the efficiency of bolted connections. Do you understand this? Okay, thank you.